Fuel was scarce, loads were heavy, breakdowns were expensive. These trucks didn't care. They survived bad fuel, brutal drivers, and the worst decade in trucking history. And many of them are still working today. This is 10 1970s trucks that survived fuel crisis and abuse. Number 10. White Motor Company Road Boss. The White Road Boss was born into one of the worst possible decades for trucking, and that timing shaped every part of its design. When fuel prices spiked and diesel availability became uncertain, fleets could no longer afford trucks that demanded constant throttle input or high-rev operation. The Road Boss survived because it didn't rely on speed or excess power. Instead, it delivered steady, predictable torque through conservative gearing that kept engines operating in efficient RPM ranges. Drivers didn't have to fight the truck to save fuel. The machine naturally encouraged smooth, disciplined driving, which mattered enormously during rationing periods. White Motor Company also understood that fuel crises didn't come alone. Maintenance budgets shrank at the same time, and trucks were kept in service far longer than planned. The Road Boss handled this reality with remarkable resilience. Its frame rails were thick and straight, resisting the twisting fatigue that long-haul and industrial routes imposed. Suspension components were simple, heavy, and rebuildable, designed to survive potholes, rough loading docks, and uneven rural roads. When abuse happened, and it always did, the damage was gradual, not catastrophic. What truly allowed the Road Boss to survive the 1970s was its mechanical honesty. Fuel systems were purely mechanical and easily adjustable, allowing operators to fine-tune performance based on fuel quality and availability. Cooling systems were oversized, preventing overheating during slow, fuel-saving driving or long idling periods common during shortages. Electrical systems were minimal and robust, avoiding the parasitic losses and reliability issues that plagued more complex trucks. In fleet service, Road Boss trucks became known for their ability to stretch time. When companies postponed replacement purchases due to economic uncertainty, these trucks simply kept working. Engines were rebuilt, transmissions were swapped, axles were re-geared, and the frame remained worth saving every time. Many Road Boss units survived the fuel crisis not because they were efficient on paper, but because they wasted nothing: fuel, parts, or patience. In a decade defined by scarcity, that restraint was the ultimate advantage. Number 9. International Harvester Transstar 4200. The International Transstar 4200 earned its place in trucking history by doing exactly what the 1970s demanded: staying predictable when everything else wasn't. Fuel prices fluctuated wildly, supply interruptions were common, and fleets were forced to operate on razor-thin margins. The Transstar survived because it delivered consistent fuel consumption and mechanical behavior, allowing operators to plan routes, budgets, and maintenance with confidence. Unlike high-strung trucks that punished inefficient driving, the Transstar rewarded smooth operation and steady speeds, making fuel conservation a natural outcome rather than a constant struggle. International Harvester built the Transstar around proven components rather than experimental ideas. Engines were chosen for long service life and stable fuel curves, avoiding sudden spikes in consumption under load. Gear ratios were selected to keep engines relaxed during highway cruising, which reduced fuel burn and mechanical stress simultaneously. During fuel shortages, drivers often slowed down to save diesel, and the Transstar tolerated this without overheating or driveline strain, a crucial advantage when idling and low-speed operation increased. Abuse was unavoidable during the decade. Trucks ran overloaded, routes were extended, and maintenance intervals were stretched. The Transstar handled this punishment with structural integrity that few competitors could match. Its frame resisted long-term fatigue, and its suspension absorbed repeated shocks without transferring damage into the chassis. Electrical systems were straightforward, reducing failure points and parasitic losses that wasted fuel and time. Perhaps the Transstar's greatest strength was rebuildability. Fleets didn't discard these trucks when engines wore out. They rebuilt them. The underlying structure justified the investment. Many Transstar 4200s survived the fuel crisis simply because replacing them made no economic sense. They were already paid for, already understood, and already reliable. In a decade where survival depended on minimizing uncertainty, the Transstar didn't surprise its owners, and that reliability kept it working long after less disciplined designs disappeared. Number 8. ERF EC Series. The ERF EC series emerged in a Europe hit hard by fuel shortages and economic instability, and it survived by rejecting unnecessary complexity. ERF's philosophy was brutally practical: use proven engines, avoid experimental systems, and build a chassis that could endure years of abuse without structural compromise. During the fuel crisis, this conservative approach paid off. Engines delivered steady, manageable power that discouraged aggressive driving and excessive fuel use. Operators could tune performance for economy rather than speed, a critical advantage when fuel availability was uncertain. ERF trucks also excelled under physical abuse. Quarry route, industrial haulage, and bulk transport punished vehicles daily. Yet the EC series absorbed this punishment without cracking or distortion. Frames were heavy and conservative, resisting fatigue over long service lives. Suspension systems prioritized durability and rebuildability over comfort, allowing operators to keep trucks running even as conditions deteriorated. Maintenance simplicity became a survival trait in the 1970s. ERF avoided proprietary components wherever possible, meaning mechanics could source parts easily and perform repairs without specialized tools. Electrical systems were minimal, reducing parasitic losses and reliability issues. Cooling systems were generously sized, preventing overheating during slow, fuel-saving driving or long idling periods. The EC series didn't survive the fuel crisis by being efficient in isolation. It survived by being manageable. Operators understood these trucks completely. They knew how they behaved, how they consumed fuel, and how they aged. That predictability reduced waste, downtime, and panic. In a decade where many trucks failed because they demanded ideal conditions, the ERF EC series thrived by accepting reality and working within it. Number 7. Magirus-Deutz 2030D. The Magirus-Deutz 2030D approached the fuel crisis from a completely different angle, and that difference is exactly why it survived. While most manufacturers focused on refining cooling systems and fuel delivery, Magirus eliminated an entire vulnerability: liquid cooling. Its air-cooled diesel engines removed radiators, hoses, water pumps, and coolant from the equation entirely. During the 1970s, when trucks often sat idle due to fuel shortages or rationing, coolant-related failures became common. Magirus trucks avoided those problems altogether. Fuel efficiency came not from high technology, but from restraint. The engines were slow-revving and torque-focused, delivering usable power without encouraging wasteful driving. Poor fuel quality, another reality of the decade, didn't cripple these engines. They tolerated contamination and variation better than many liquid-cooled designs. Structurally, the 23D was built for export markets and harsh environments, making it well-suited to the unpredictable conditions of the fuel crisis. Abuse only reinforced its reputation. Mining, military logistics, and infrastructure projects relied on Magirus trucks because they continued operating when others failed. Maintenance access was excellent, and mechanical systems were logical and robust. When parts were scarce and fuel unreliable, fewer systems meant fewer failures. Many Magirus-Deutz trucks survived the 1970s, not because they were the most efficient, but because they removed entire categories of failure. In a decade defined by shortages, that radical simplicity became their greatest strength. Number 6. Leyland Marathon. The Leyland Marathon was conceived at a moment when excess had become a liability. In the 1970s, fuel was no longer cheap, routes were longer, and fleets could not afford trucks that encouraged aggressive driving or high RPM operation. Leyland responded with a truck engineered for endurance rather than performance. The Marathon's power delivery was deliberately restrained, producing steady torque that allowed drivers to maintain momentum without constantly dipping into fuel reserves. Gear ratios were chosen to keep engines relaxed at cruising speeds, making fuel consumption predictable even under heavy loads. What helped the Marathon survive the fuel crisis was its ability to operate efficiently without demanding ideal conditions. During fuel shortages, trucks often ran slower, idled longer, and stayed in service beyond planned lifespans. The Marathon tolerated all of this. Its cooling systems were oversized to handle extended low-speed operation, preventing overheating when drivers conserved fuel instead of pushing speed. Electrical systems were simple and robust, avoiding failures that could strand trucks when replacement parts were scarce. Abuse in the 1970s often came quietly. Trucks weren't smashed or wrecked. They were simply worked longer than intended. The The Marathon's frame resisted fatigue over extended mileages, and its driveline components wore gradually instead of failing suddenly. That gradual aging allowed fleets to plan rebuilds rather than suffer breakdowns. In a decade where capital spending was frozen, this predictability mattered more than outright efficiency. Many Leyland Marathons survived because they became known quantities. Operators understood exactly how they consumed fuel, how they aged, and how far they could be pushed without risk. That trust kept them in service long after newer, more complex trucks were sidelined. The Marathon didn't fight the fuel crisis. It adapted to it by staying calm, conservative, and dependable. Number 5. GMC Astro. The GMC Astro became an unlikely hero of the 1970s fuel crisis by thriving where fuel waste was unavoidable. Cities, stop-and-go traffic, short hauls, and frequent idling punished fuel economy, yet the Astro's cab-over design helped offset those losses. By maximizing cargo length within shorter overall vehicle dimensions, fleets could move more freight per trip, reducing total fuel consumption even if per-mile efficiency wasn't exceptional. The Astro's survival also came from balance. Its engines were matched conservatively to transmissions, preventing excessive fuel burn during acceleration. Drivers could operate smoothly without fighting throttle response. The tilt cab design made maintenance easier and more frequent, a crucial advantage during a decade when deferred service often led to catastrophic failures. Because mechanics could access engines quickly, Astros were less likely to suffer from neglect-related breakdowns. Urban abuse was relentless. Curbs, loading docks, potholes, and constant braking stressed frames and suspensions daily. The Astro handled this punishment better than many conventional trucks thanks to its compact wheelbase and balanced load distribution. Less frame flex meant less long-term fatigue. Electrical systems were straightforward, reducing parasitic losses and reliability issues during long idle periods. Many Astros survived the fuel crisis, not because they were the most economical trucks available, but because they made economic sense. They were easy to keep alive. When fuel was expensive and downtime unacceptable, fleets chose trucks that rewarded maintenance rather than punished neglect. The Astro didn't disappear when the decade ended. Many stayed in service well into the 1980s and beyond, proving that practicality is often the most resilient form of efficiency. Number 4. Foden S20. At first glance, the Foden S20 seemed out of place in a fuel-starved decade. Its heavy steel chassis and industrial build didn't scream efficiency. Yet that very construction is what allowed it to survive when lighter, more delicate trucks failed. The S20 was engineered around durability first, fuel economy second, but in the 1970s, durability often proved more economical in the long run. When fleets couldn't afford replacements, trucks that could be rebuilt indefinitely became invaluable. The S20's steel frame resisted fatigue under constant heavy loads, a critical advantage when trucks were kept in service far beyond planned lifespans. Engines were deliberately detuned, trading peak power for smoother, more efficient operation. That restraint reduced fuel spikes and mechanical stress, helping the truck survive both the fuel crisis and the abuse that came with stretched maintenance schedules. In industrial and construction roles, the S20 absorbed punishment daily. Poor roads, heavy trailers, and inconsistent loading conditions didn't overwhelm its structure. Cooling systems were robust enough to handle low-speed, fuel-saving operation without overheating. Electrical systems were minimal, reducing both failures and parasitic losses. The S20 survived the fuel crisis because it aligned with economic reality. Operators rebuilt them rather than replacing them, confident that the frame and core systems were worth saving. Fuel efficiency mattered, but so did predictability. The S20 delivered both by aging slowly and honestly. In a decade where many trucks became disposable, the Foden S20 proved that old-fashioned strength could be the ultimate form of efficiency. Number 3. Steyr 90 Series. The Steyr 90 Series was shaped by terrain where fuel efficiency isn't optional. It's survival. Designed for alpine routes, steep grades, and harsh weather, these trucks entered the 1970s already accustomed to operating under pressure. Their engines delivered strong low-end torque, allowing drivers to climb grades without excessive throttle input. That naturally limited fuel consumption, a critical advantage during shortages. Abuse came not from overloading alone, but from terrain. Constant elevation changes, poor roads, and extreme temperatures punished every system. The 90 series handled this with durable drivetrains, excellent traction setups, and frames that resisted twisting. Cooling systems were engineered for sustained load rather than short bursts, preventing overheating during slow climbs when fuel-saving speeds were necessary. During the fuel crisis, Steyr trucks proved their worth by being predictable. Operators knew exactly how they behaved under load, how much fuel they consumed, and how they aged. That predictability reduced waste and downtime. Many Steyr 90 series trucks survived the decade because replacing them offered no advantage. They were already efficient where it mattered most, in real-world conditions. Number 2. International Harvester. Loadstar. The International Harvester Loadstar wasn't the biggest truck of the 1970s, but it may have been one of the smartest responses to the fuel crisis. As diesel prices surged and availability tightened, many fleets realized that survival didn't always mean hauling more. It meant wasting less. The Loadstar fit that reality perfectly. Designed as a medium-duty workhorse, it paired modest, efficient engines with gearing that favored usable torque over speed. Operators could complete routes with fewer gallons burned, which mattered enormously when fuel allocation was uncertain and budgets were shrinking. What allowed the Loadstar to thrive wasn't just efficiency, it was forgiveness. During the fuel crisis, trucks were often overworked and under-maintained. The Loadstar tolerated missed services, inconsistent fuel quality, and stop-and-go abuse better than many heavier competitors. Its mechanical systems were simple and accessible, making field repairs realistic. Electrical layouts were straightforward, reducing parasitic losses and minimizing the kinds of faults that sidelined more complex vehicles during long idle periods. Structurally, the Loadstar punched above its weight. Frames were strong enough to handle repeated loading cycles without fatigue cracking, and suspension components absorbed urban punishment, curbs, docks, potholes, day after day. Many Loadstars were overloaded regularly because fleets couldn't afford additional trucks. Instead of failing suddenly, they wore gradually, giving operators time to plan repairs. Engines were rebuilt rather than replaced, transmissions refreshed rather than discarded, because the chassis remained worth the effort. Perhaps the Loadstar's greatest contribution during the fuel crisis was economic stability. It gave fleets a truck they could understand completely: predictable fuel consumption, predictable wear, predictable maintenance costs. In a decade defined by uncertainty, that predictability was priceless. Many Loadstars survived not only the fuel crisis but decades beyond it, transitioning from primary fleet duty to municipal work, yard service, or regional hauling. They weren't glamorous, but they were dependable, and dependability kept them alive. Number 1. Tatra 8113. If there was one truck that seemed almost indifferent to the fuel crisis, it was the Tatra 81. Introduced with a design philosophy that ignored conventional trucking norms, the 8113 was built for environments where breakdowns simply couldn't happen. Its defining feature, the central backbone tube chassis with independent swinging axles, changed how stress traveled through the vehicle. Instead of concentrating fatigue in frame rails, forces were distributed evenly, dramatically reducing long-term structural damage. That single decision allowed the Tatra 8113 to survive abuse that destroyed conventional trucks. Fuel efficiency on paper wasn't the 813's priority, but real-world endurance was. Its engines delivered steady, low-revving torque that discouraged aggressive driving and reduced fuel spikes. In a decade where fuel quality varied and supply was unreliable, that restraint mattered. The 813 didn't demand perfect conditions. It accepted bad fuel, long idle periods, and heavy loads without complaint. Cooling systems were engineered for extreme operation, and drivetrain components were sized for continuous stress rather than peak output. Abuse was constant. The Tatra 8113 worked in mining, military logistics, forestry, and infrastructure projects, often overloaded, often off-road, often far from service support. Maintenance intervals were stretched not by choice but by circumstance. Yet the truck survived because its core architecture didn't fatigue the way conventional designs did. When parts wore out, they were replaced. The chassis remained intact. Owners rebuilt them because replacement offered no meaningful improvement. What elevates the Tatra 8113 to the top of this list is longevity beyond economics. Many trucks from the 1970s survived because they were cheap to keep running. The 813 survived because nothing else could do its job better. Even today, decades later, its engineering philosophy remains relevant. Modern Tatras still rely on the same backbone concept because it works. In a decade defined by shortages and stress, the Tatra 8113 didn't just survive the fuel crisis, it proved that radical durability is the ultimate form of efficiency. So that's it for today. If you like this video, then please hit the like and subscribe button for more videos. Thanks for watching.